All right, welcome to class today. Today, I don't really have any updates on the ArcGIS portal situation, but we're going to proceed with ArcGIS, using ArcGIS Server. Now, on the syllabus, I originally had using open source tools for publishing this week. But I think that what we're going to do is move around a few things. So today we'll start talking about ArcGIS. We'll start talking about server-side processing. So being able to basically create a program, a custom program, that will execute on the server whenever you want. Ideally, it gets worked into a web map. And we'll talk about putting it into a web map next week. So today we're going to talk specifically about creating a program. Now, you could do this from scratch. There are a lot of tools that allow you to write a program that can be accessible from the web. So I have some people in here that have taken a Python programming class before, right?
Yes, sir.
Yeah, in this class. And probably, maybe there's somebody who's even taken a Java programming course. Not JavaScript, which we've used in this course a little bit, but Java, anybody? Maybe not. Okay. Well, there are a few other languages that are used for writing web services, but those are some of the major ones. Okay? They have several advantages. One of them being that both of those languages are cross-platform. In other words, they run on Linux, they run on Mac, they run on Windows, they run on all of those. And so there's a toolbox. There's several. Sorry, not toolbox. There's several modules for Python. For those of you that have taken a Python course, there are several modules for creating web services. Probably the most basic one that people get started with is called Flask. Micro framework for creating web services. I'm not going to actually demonstrate it in this course, but you can write a short Python program, and it's showing you this short Python program here. And once you create that program, this program here, I'll make this a little bit bigger. Once you create that program here, it imports this module called Flask, and it creates one single variable called an application. And this is required to create the call in, basically to start running the code that is waiting for a request to come in from another computer. And then you can actually set up various locations for it to listen for. So in this case, it's just saying, with a slash, without anything else, it's saying listen at the main location. So if this was running on a computer, it could be accessed by gis.usm.edu, for example. This would be running at the main root, so gis.usm.edu. And then if you ran that, it would execute this function, which would return the text, hello world. It'd be, that's a silly example, or a basic example. But it would run that, and it would be available for anybody to go, and if they went to that web page, it would just say hello world. But you could modify this further so that you could have different slashes here. So you could have slash, give it a label, slash point here is that you can modify the URL address to your choosing, and you can control what's returned to the user in Python code. So you could return whatever you wanted. You could return GeoJSON features. You could return coordinates. You could return information that you accessed out of a database. You could really, anything that's programmable, you could return back to the user doing something like this. So Python has this ability, but it's not the only programming language. As I said, Java is a fairly common tool for doing things like this, writing web services. And kind of like the ArcGIS, well, not kind of, exactly like the ArcGIS REST interface. This is what I'm talking about. Here's our ArcGIS REST interface. See, every time I go to a page, like my first web map, I'm just setting up the different slashes after the main thing, and then there's code that's running that's putting up that information. Okay? This web page doesn't actually sit on the server anywhere. It's just code that creates that web page based on information that's set up on the server. So that's one way that people write web services. Now, actually writing our own web services is beyond the scope of the class, but that's how, a program like this is how something like this gets created, where we have a bunch of requests that we can make to various things, various aspects of GIS data. ArcGIS, and there are other tools that do this, they expose a method for taking a shortcut. So that if you know a little bit about creating GIS processes, then you could create a GIS process and get around the having to write one of these from scratch. Okay? That's called a geoprocessing tool, and that's what we're going to learn about today in ArcGIS. So what I want to do is start off with an example that's kind of like the example here, where it says "Hello World" or something similar, and then we'll progress to actually interacting with geographic data. All right. So probably shouldn't have left this up from last week, but I'm going to make a blank template here. Or sorry, open up a new version of ArcMap. So the way that you create a geoprocessing service is that you create a toolbox. Has everybody here created a toolbox before? Anybody not created a toolbox? Okay. So I'm going to create a toolbox. There's a few considerations we need to do when we're building a toolbox that's going to be used as a geoprocessing service. And we'll talk about that as we progress. So the first thing to do is to add a toolbox. There's no new toolbox. Notice when you right-click, there's no new toolbox. But there is a toolbox. We're going to do this in ArcMap again instead of ArcGIS Pro, because this actually is functionality that is newer in ArcGIS Pro, but it's a similar workflow. All right, so you have to find out where you're going to save it. It really doesn't matter where you're going to save the local copy of the toolbox on disk. Again, like with the MXD that we did last week, you just want to make sure that it's in a place that you'll be able to remember, and that you name it something that that you'll be able to link to the service that actually gets created. It's helpful if they're named to the same thing, but you're actually given the option to rename it on publishing, just like with your map document. So I'll put this in ctemp. I'm going to create a toolbox, a new toolbox. And I'll call this new toolbox web, let's call it web mapping toolbox for now. So anyway, I interrupted myself in that thought. There's no add new toolbox. You have to hit add toolbox, and then inside the add toolbox area, you have to hit this little button, the new toolbox button. So once you do that, you'll have a web mapping toolbox there. And when you first open it and add it to our toolbox, it will be an empty toolbox. Now, you can't even expand it because there's nothing there. All right, now what kind of custom tools can we put into our toolbox? There's basically two different kinds of tools that we can put in our toolbox. What are those from somebody who's taken a class like this before? A box? Okay, you're right. We can create a new tool set. I think that's what you might be referring to. Yeah, tool sets are kind of like folders for tools. So they're not necessary, but we can create them. Basically, what I'm trying to say is that we can create a model, which is a graphical interface that allows us to program our tool graphically. And then the other one is a script tool. And since this isn't a class on scripting, we won't get too far into it, but I'll demonstrate how you could write a script tool. And being able to script your own toolboxes is very powerful, and especially when you're doing this on the web, there's even more reason to be able to write scripts so that you can get your output exactly the way you want it for the web. So it's an additional bonus to be able to create a script tool. So first, let's just do a new model. So here's a new model. In ArcGIS, I don't like it how it comes up with the default name, and you basically have to close it and then rename it to get it named something. I'm going to name this one. I'm just going to call this find value. I'm not going to do that. I'm not going to do the hello world. Actually, let's do that. Let's do hello world. I was going to add two numbers, but we'll change it a little bit. We'll just call this hello world. And hello world is going to be our first tool that we create in our toolbox. If we go to properties, make sure that the name is actually hello world in both cases. All right, now you're going to have to publish these into your own folders if you publish along with me, because if you don't, it will overwrite or give you an error, depending on how we do that. So now I've got my little module called Hello World, and I'm just going to write a tool that has, when you think about, maybe I should back up just a little bit. When you think about the tools that you're going to create for our toolbox, that are eventually going to become services, you need to think about what the inputs are going to be and what the outputs are going to be. So if you want your website, if you want your user to be able to click on a location and then return something, let's say. Think about that. The input is the click. The output is the information that you want to return to the user. You might want them to click and then provide some additional information. Like let's say you're making a buffer. Maybe that'll be our second example. We want to be able to click, buffer, and then return all of the features that are within that buffer, or estimate the population within that buffer. That might be a little bit better because we can already return all the features just in the REST interface the way it is. We could have a click and say, return all the features within a certain distance. Well, if we actually wanted to buffer, intersect, and then estimate the number of people living in a certain area, that might be a valid geoprocessing tool. So in our case, I'm going to think about this, and it's similar to the Flask example. When the user executes this tool, I want the return to be hello, but instead of world, I want the return to be hello and then the name of the input. So the input is going to be a name, the user supplies a name, and then the service responds hello to that name. It'll be pretty basic, but it'll illustrate the example. All right, there is a tool. Sorry, did you raise your hand? Okay. There is a tool in ArcGIS. It's in ArcMap, it's in ArcGIS Pro, it's in both. It's a simple tool called Calculate Value. And Calculate Value allows you to provide it an input, and then it will modify that value. It's not the same as Calculate Field. Okay, Calculate Field, it does a very similar thing, but it puts the value in a field and it does it over and over and over for every row in the field. This doesn't do that. This just creates a single value. It's used a lot in models for providing the data set name based on a few inputs. It's really a helper, but all it does, it actually technically what it does is it executes a single line of Python code and returns the result. So I'm going to hit Calculate Value. That's going to be the only input, the only tool that's executed here. So I've got my Calculate Value tool, and that's the output value. So one of the things that I could do here is, if I double click on this guy, I have an expression that I can put here, and my expression will is the single line of Python code. And I actually said it executes a single line of Python code, but more correctly, I should say that it can execute an entire Python function. This does not, I think it used to, allow you to specify whether you're talking about Python or Visual Basic, Python 3, but it doesn't do that anymore. It only runs in the native version of Python for that particular version of ArcMap or ArcGIS Pro. So here it's 2.7, in Arc Pro it's 3, Python 3. But in almost all cases, they're very, very similar. Okay? So we want our expression to evaluate to hello and then the name. So what we could do is just write, hello. You got to put it in quotes. I'm going to put a space afterwards and say plus, because that string, in Python, plus is a string concatenation. I want to put two strings together, I use plus. It's actually the same in JavaScript that we've been working on in this course. So I say hello, and then I need to insert the name of the person. So I'm going to put, this is how you do this. This might be a review for some people, it might be brand new for others, but you say %, given name percent, and where given name is actually a variable. We haven't created that variable yet, but it is a variable. And then the output, we're going to change that to be a string, because we know that it's going to be a string. So notice that we've got a bunch of things here. We've got feature class is here. We've got feature class right here. So we could actually write a Python program. Let's say that we had a whole shapefile directory full of a whole directory full of shapefiles. We could actually use this tool to publish, to create a temporary published version of any shapefile in that whole directory. And maybe that's an example that I'll show later, but we're going to right now make this the output a string. So a string is basically means text. So the output's going to be text. So that's all we need. Say OK there. And now it's ready to run. We could execute it right the way it is, but it would actually fail because we haven't set up that given name input variable yet. So we have to do that. So we can right click and say create variable. We have to do this whenever we have used that inline variable substitution. That's what we did here with the percent given name percent. That is considered an inline variable substitution name. So we got to create a variable for that, which is also going to be a string. str doesn't show up qr. Just go to it then. String. And we could rename it. We have to rename it because we've already said it's given name. It is case sensitive, so given name. I did this thing. It's sometimes programmers refer to it as camel case, where if you stick words together, every time it's a new word, you capitalize that word. So I said given name capitalized. Okay. All right. Now I'm going to right-click on this guy and make it a model parameter. That means that it's a parameter that's required to be input for my model. And then I'm going to right-click on this guy and make it a model parameter. ArcGIS is smart enough to know that that's the output, that that's the result, and that you won't need to actually supply that value, but you do need to make it a parameter, otherwise it won't run. See how it's like, well, it's not great out there. But it knows that you need to make the output a model parameter. Otherwise, it won't know that it needs to give that out to the resultant the resultant geoprocessing service. And the last thing that we need to do to actually make this run is give this a default value. Even if your input is a map click or a point, you must give it a default value, or it won't work. So you need to give it a default value. Here, it's just the given name, and I'm going to write my given name, which is George. So now everything's colored again. It means it's ready to run. So I hit save. Now this next thing is important to remember. You cannot just run it from right here. You can't hit run. I mean, you can test it. So I'm going to hit run and test it. Name George is not defined, so I messed up here. Oh, yeah, I know how I messed up. Okay, so back into calculate value, you actually have to put a quote around given name. Otherwise, it thinks it's a variable named George. So quotes around given name. Sorry about that. So maybe it is a good idea to run it here. Okay. So it ran. Ran. It says it's already run. That's fine. So you got to make sure you save it. And you can't just run it from here, because what you're actually publishing is the geoprocessing result. So if I look over here under geoprocessing and look at results, there's nothing in the current session. It hasn't run yet as a result. I actually have to close it and run it by executing or double clicking on the toolbox. Now, one of the things that's important to remember here is that at this point, it's going to run. So whatever data you have it running on, and whatever result you have it finishing up on, are going to get copied to the server. So if it's possible, it's kind of good to run it on a small area, or the smallest feature you can run it on. It's good to have it run on some small data, even if at the end you're going to actually have it run on a larger area, or you're going to have, typically you're going to run it bigger. You can test it that way, but the one that you actually go to publish, it's best if you make it the smallest example possible, publish it, and then you can use it for a larger area. Just because it's going to have that the default values are going to be your this run, the run that you're going to publish. So I'm going to hit OK and actually run it here. And now it shows up. I moved it off the screen here. That's fine. But now it shows up here under current session. I have my hello world. I have my output value. It says hello George. So it's ready to publish. My service that doesn't do much, but it's ready to publish. So now if I right click on it, I can share as a geoprocessing service. A geoprocessing service and geoprocessing package are very, very similar. But a geoprocessing package is one that you can, it basically gets it all ready, and then you could email it to somebody and they could open up your geoprocessing package and be ready to do the same processing. So it doesn't like put it on the cloud. Geoprocessing service puts it on the cloud. It puts it up on our hardware. That's the one that we want. Geoprocessing service. I'm going to make sure that I say I'm going to publish a service. And if you're working on a different computer than you were last week, you have to remember to set up our gis.usm.edu service, which you would do right here by pressing this button, saying administer, and then filling out this information. I did put the username and password up on Canvas on the lab for last week. But I didn't put this information up. I should remember to do that. But ours wouldn't be any different, except for under geoserver.domain.com, you'd put gis.usm.edu. We don't have to do that because we set this up last week. We're all ready to go. So we choose gis.usm.edu. The service name is going to be Hello World. I'm going to make sure that I put it in the Raber folder so that if any of you are following along, you'll be able to publish yours as well. I'm going to hit continue. All right, there are a bunch of options here that we went through last week when we talked about map services, and we'll do that again in a few minutes when we do this with actual geographic data. But for now, there's not a whole lot of things that we need to change here. Some of them are very similar, like the pooling option. We don't need to go over that again. Under parameters, there's a minimum number of records returned by the server. That's the same. Okay, we don't really need to go over that. Basically, if you want to be able to return more than 1,000 records, you need to change that. But don't get crazy, otherwise it'll take too long. One thing I do want to talk about here, right now, before we publish actual processing data, is that there are two different types of services that it could create. One's called a synchronous request, and one's called an asynchronous request. And this is actually pretty important when you go to publish your own geoprocessing services. And the difference here is that with a synchronous service, when you send a request, it sends the results back, which is the way you think it should work, right? You put in a URL, you say, okay, here's the information. Okay, the given name's George. So you give me back, hello, George, right? That's the way you think it should work. Well, that works great if you know it's going to run very, very fast. So you get a request, you send out a request, George, and it responds back, hello, George. But if you're running a process, you send a request off, and the request is, tell me how many people live within 100,000 miles, because somebody gets crazy and writes 100,000, of New York City. That could take a little while because the buffer is so large, and it could be trying to calculate the population of the whole world. It could take a long time to do. And so choose asynchronous in those cases, because what asynchronous does is that when you send your request, the response is, okay, here's your job number, hold on to that. And then the client gets the job number back and can periodically ask the server, did you finish my job yet? Hey, did you finish my job yet? It's asynchronous. And so that's what that does. It instantly hands back a job number. And this is for situations where you think that it might take probably more than about 10 seconds to respond to the service. You'd want to do asynchronous, particularly if you expect it to last minutes, because most web browsers will say the server's taking too long to respond. You've probably seen that, kind of an error at a website. The server's taking too long to respond. Should I crash or what? Or sometimes it just crashes. It doesn't load. So asynchronous is what it does is it allows the server to instantly respond with the job number. And then you're responsible for checking back and asking, is it complete, is it complete, is it complete? Which does use some more resources on the client, because the client has to have a timeout function where it's just waiting for it. But that can be hid inside the code. So for ours, which one do you think is more appropriate? Yeah, synchronous. It's really, really fast. It says recommended for long-running services there already. What they mean by, I think, typically on the web, most cases, somewhere between 10 and 20 seconds is probably the cutoff of a long-running service. That where you should really do an asynchronous request. Okay. All right. None of these others we really need to do here. Obviously, when we say when you say asynchronous, you're given the result to view the results with a map service. We don't really need to do that, or we can't do that. There's no reason to do that because we're just outputting a string. All right. Talk about some of those others later, but under parameters, synchronous, that's really all we need for now. If you hit analyze, what it does is sees if there are any barriers to you publishing your data. And the only one that we have is that we didn't fill out those annoying things, same as last week. There's 2 fields where we have to put something. So those are under your parameters. By the way, these are your parameters right here. Every parameter that you have will show up there. So we've got given name as the parameter, and we've got output value as a parameter. So they'll show up in those places, and you need to modify those values. You need to put the description. So this is type your, or tell me your given name. You just need to put something there, otherwise it won't run. Same with output value. Here I will say hello. Something like that. Now once you're done with that, you hit analyze again, should be fine. It's just telling us the tags, other text stuff is missing. Make sure I turn that down actually. Okay, so then I can hit publish, and this will publish pretty quickly. Pretty quickly. It's it would copy any data it needs up onto the server, as well as the program itself. So now if I go to the server, you'll see that I have a service under Raber called Hello World. And I can click on it. And if I click on it, there is a task called Hello World. I don't know why ArcGIS does that. It doesn't change anything in ArcGIS Pro, same way, where it puts the task inside of a toolbox called the same thing. So the URL will always look like that, where it looks like this, hello world /gp server /hello world. And now if we want to actually run this process, we can hit execute task. We can type whatever we want here. This is the power of the service. Okay? Although this service isn't very interesting, it's powerful. I can put in Bill, and the code still runs. The Python code that's running in the background is going to say hello Bill instead of hello George. So when I run it, I get the output value, hello Bill. So there's my result, hello Bill. I can change it, I can put any name in here, hello Oscar. And if I want to actually output this as JSON, I could hit F equals JSON. So now I've got that outputted as I changed the F equal from HTML to JSON. Did that too fast. Over here, it says F equal, it used to say F equals HTML. I changed it to F equals JSON. Think.
You hit the get or the post?
Yeah, if you hit get, it'll work a little bit better. I don't think that it matters too much though. Okay, so there's pretty JSON. Let's see what happens if I hit post. Yeah, it's the same. The only difference is you see that it didn't update the query string. So post doesn't actually send the request in the query string. It sends it as a separate attachment. So by default, everything gets sent post if the query string is really long. Remember we had an example of that last week. So I like doing get because you get to see the whole string that's being sent to the program. PJSON. So if we tried to put this week, we won't do that. We won't build any websites this week. We'll take a week off from doing that. But if I did want to access this in a, I guess I could do this without setting up a whole map. So maybe I'll just do that one thing this week. But, so the only thing I'm going to add here is jQuery. That's all I'm adding. I'm not going to add anything else. And yeah. Then I'll write a simple here's a little bit of code that you send to a URL, and I just need the URL to this guy. To execute. Oh wait, I want to get the whole thing. Yep, that's good. Put that in there. Let's see if this works. No, something's not working. Doors. Oh, that's the same issue we were having last week. We have to make sure that it's loading over HTTPS. And it's 6443 for the HTTP. That's it. Okay. So HTTPS 6443, and that should work. So once you do that once, that other URL will work. But you have to do it once per machine. Go. Okay, so it looks like it's expecting a different type of data, but this is the return. I'm just going to change this so that for each data. Like this, data dot, so look at this, it's data dot results 0, data dot results value. There you go. So now it says hello Oscar there. So the way I got this was that I had to understand how the output value was going to look. F equals P JSON. There you go. So squiggly brackets mean that it's a object. And so inside that object, there is one thing. It's called results. There's only one attribute of this object. It's called results. And results is an array, but that's what the straight brackets mean. So I say I want result 0, and I want the value of result 0, which is going to be hello. And next week, when we program this into to a web app, we'll see that it's a little bit simpler notation, but you still have to understand which result it is in order. Is it result 0, 1, 2, or 3? Most of the time, in most geoprocessing tasks, you only have one result. So that's why it's result 0. Then dot value will return the actual value of that result. And if I wanted to change this value here, instead of Oscar, I could put in George. Now should update. I might have to refresh the page.
I have a question.
Yeah.
So I changed the URL to HTTPS and then copied and pasted it over, and mine is still not showing up on the left-hand side like how yours says hello Oscar.
Okay.
But I have like the same thing, like everything copied and pasted just like yours.
Now I'm having an error. Well, you could just send me your code pane. I could see what the problem is.
I think the difference here is JSON and mine's JSON.
That shouldn't matter. Now I lost mine altogether. There it is. I'm still having that error. I don't know why. My error says unexpected token. Yeah. Mine worked at the beginning, but now I'm having the error. Oops. Is it no? After value? Where's value? Oh, right here? Oh, instead of yeah. Yep. That's exactly it. Okay. All right, yeah, so now I can go hello George. I wonder why it even worked ever. I can change it back to Oscar. You may have to get it to rerun. But the point here is I could actually have a text box where I enter their name and they could use jQuery to get the name that they entered and then run this process and have it type that name. Of course, I could do all that in JavaScript. Okay? There's no reason right now. There's really no reason to have this process that runs on the server that writes hello George. Just it's just a basic example of the architecture that needs to happen in order to, or that the architecture that ArcGIS is set up so you can run any program that you can, anything that you can do in ArcGIS, you can set up as a geoprocessing service. All right, so that's a simple one. So the workflow is you create a toolbox, you create a tool in your toolbox, and your tool can either be a model, in other words, using Model Builder, or it can be a Python script. It doesn't matter. You're free to do either one. And then you have to run your tool, and you have to publish the result. You have to run your tool from the Our Toolbox dialog, not from the editing version of it. So that's the workflow. It's fairly simple. So let's do something. Let's do something geographic, where we provide an input, a geographic input, and we get a geographic output. So before we go there, let's do that. I was going to think of a step in between where we didn't provide a geographic input, but that's okay. Okay, so we can go ahead and create our next tool right inside of this tool. So let's create a new model. We're going to rename this Find Population. So it's going to find the population of a user click. So we click on it, and we're going to know what the population is inside that click. So we're going to have a location and a buffer around that location. And we'll let the user choose what that buffer is. So first, let's get some census data. I'll go to Maris and download some census data of the last census. Population and housing. Yep. Wow, that's bigger than I thought. I wonder if this one's any smaller. Well, actually, yeah. Kind of cool to do blocks because it's really detailed. Oh no, so it's 164 meg. That's not too bad. I guess population and housing, that should be everything in the census. The sex, race, and age is probably a subset. That might have been. Let's see how big that is. Oh, it's bigger. I'm going to open this when it's done. Maybe I should have done the track level data for the example. See how big that is. Only 9.2. Yeah, let's do that. No, it doesn't really matter, but I'm going to do the track level for the example because later we're going to upload this data to the server and it's smaller. So I did the track level population and housing data. So I'm going to open that, and I'm going to copy this somewhere where I want to utilize it. I'm going to put it on C, temp, and I'm going to call this new directory MS census. I'll put it all in there. I could copy the other data in later, or the block level data. So now it's got that data. Here's the metadata, so I can see which one of the fields is the population field. That might be important. Okay. Total population. Interestingly, we could, that's probably what we'll do, is we'll use total population, but later we'll let the user supply the field, and then you can find out, you know, any whatever value you wanted. This is not all the values. So we could find, you know, the total Hispanic population, or just the total population, or both. Still don't understand why this is not showing me the whole field. But in any case, I'm going to close that down. And I'm going to go back to ArcMap. And I have to put the data into ArcMap, but technically you don't have to. But I'm going to because I want to see it. CTemp, US, no, MS census, and put in these are all the tracts from Mississippi. How come the tracts are bigger in some places than they are in others? Do you know the answer to that? Yeah. Yep. I didn't hear both answers, but they're probably both correct. But yeah, the population is supposed to be roughly the same. So what we're going to do is allow the user to click, and where they click, we're going to buffer it and estimate the population within that click. So we're just going to assume that the population within every tract is evenly distributed. So this is similar to things I've done in other classes where we disaggregate by basically spreading the population out. Okay, so I've got my find population. I can edit it. The tools that we'll need here are a buffer, and then a intersect, and then let's see, we need a buffer. We buffer the thing, but before we even buffer, we need to find out what the area is, since we're not dealing with shapefiles. Actually, I think the first thing that I'm going to do is make this not a shapefile, because then the population will get calculated. It's automatic. I mean, the area will get calculated automatically. So I'm going to create a new file geodatabase in this folder, and I'll just call it MS Census. So what that's going to do is create a new file geodatabase, and I'm going to right click. Oh, that won't work. But I'm just going to say I created it there. I need to put this in there, so that can be done in the catalog window under C. Temp, and then MS Census. Do I need to refresh this? It's alphabetical. Refresh. There it is. So I'm going to import a feature class into this database, And the feature class I'm going to import is the population data. And I'll just call this MS tracks. Yes, it does. Good point. I don't know why it's not showing up there. Let's look in our catalog. Should be there. Let's do your data, export data. And put it in there. Let's see, temp.
You're putting all the CSV text files into the GHY?
No, I'm trying to put the population tracks into it. I don't understand. MS. There we go. There we go. Refresh. So now I have the Mississippi tracks inside of the file geodatabase. If I open up the attribute table, the whole reason that I did this is because it automatically creates these last two fields, the shape length and the shape area. Creates those automatically. So now, in order to figure out what the population is, all I need to do is to all I need to do is to create a new field that will hold the total area, and then I need to do the buffer, the intersect, and find out what the population total is after the buffer and the intersect. So it's a simple tool. I had in mind to do a little simpler one first. Okay, so I need to, okay, one of the things that's really important with your toolboxes is that if there's anything that's going to be done every single time, especially on a server tool, is that you do that beforehand. So we're always going to have a field that's going to be called the area, the current area, the overall area of these census tracts. So even before we start our toolbox, let's add a field and set that up. So we're going to have a field, and we're going to call this total area. And that's going to be a double. We're going to create that field. That's going to be done every single time. And then we're going to calculate this field, and it's just going to be equal to shape area. The reason that we had to do that, you might say, why do we have two fields with the same value? The reason that we had to do that is that when this executes, shape area will be updated with the new shape area. So we can't use that shape area. We have to have a field that's called total area, and then we'll find out the ratio after it runs. Okay. So now that that's done, we can go back in and edit this guy. And so now, I think if we think about our tool, all we have to do is buffer, intersect, figure out the new area, and multiply the populations by the ratio between the new area and the old area. There's another thing that we can do beforehand so that we don't have to do it in later. Okay? We're going to have to create a field called population population out or something like that, the new population field. So we might as well actually create that field right now, because that way it'll be in the data set already and we won't have to run add field, and we'll save, those few milliseconds. It's still something we could save. So if we open up our attribute table, the other thing that we could do is clean this up. If there's fields that we don't need, we should clean it up so it's working on a smaller data set. But I won't do that now. But I am going to add this field. This is I'm going to make it a long integer, only because it represents population, so we're going to round to the nearest person. Even though theoretically, well, not theoretically, we're most likely going to get some people that are rounding errors. Okay, so I'll just call this buffer pop. Stands for the population in the buffer. Okay. There's my buffer pop. It's all empty for now. It's not going to get a value until we actually run the tool. I think we're getting close here though now, all right? So now we're going to edit this, and we're going to add the buffer tool to that. Buffer is actually under analysis proximity, buffer. Okay. So we're going to be able to buffer. And let's do that. Let's handle that one first. So we want the user to be able to specify the input features. That's the point, the user click. So we want the user to be able to specify that. So we're going to specify that as a model parameter. We also want the user to be able to specify a distance. And we're going to make that a model parameter. Now, I'm not going to make this a model parameter. Why? Because there's other things to do. This is just a temporary step along the way. It's going to go from here, it's going to do that, but the next thing it's going to do is actually that intersect. All right. Now, to make this actually run, we need to have something here for input features. We need to be able to select a point. It doesn't matter if it's really a point. Like, in the end, it can be whatever, right? There is a way, let's save this. I can go into here, and I can go into the properties. See this parameter? It's a feature layer. I could go in here. Well, I can only change it as a feature class. I thought maybe there was a way, maybe it's actually in here. I thought maybe there was a way to specify that it had to be a point, or it had to be a line, or it had to be a polygon. Let's see. Now there isn't. There is something that you could do. This is called a feature set. A feature set will allow you to interactively choose it. This is actually, regardless of whether or not you're doing this to make it a geoprocessing task. Like, let's just say you actually want a tool where you want to let them click interactively. Then you can choose feature set right there. So watch how this works. I'm going to save this. You do have to put the schema. I'm not sure that it'll yeah. Okay. It's not letting me choose it interactively yet. Let's go back here to properties. No, sorry, back to edit. See where I have it set feature set? I have to select where the schema and the symbology is coming from. In other words, I have to have a data set that is going to be like the points that are going to get buffered. So whether or not you're going to use feature set or feature class or whatever, you have to give it a default data set with default values. You have to. So we need to create that default data set. It's a little bit of a pain, but we can do that right in the same directory. We can create a new feature class, and we're going to call this input. I'll just call it input underscore points. I'm going to make it a point feature class. I don't need to give it an alias. I do want it in the same projection, so I'm going to import that same map projection as the tracks, which is MSTM. And then I'm going to hit next. Here I could, if there's a reason to, I could add extra fields. Sometimes there's going to be a reason to pass fields into your geoprocessing service. If you have a data set that, if you're going to ask for the population, we could provide a multiplier or something. Anyway, this may be a bad example, or it's not really a bad example, but just if there's a reason to input fields, you could put fields in. It's just that you also have to populate those fields with values. I'm going to leave this blank if there's no reason to. By default, it will add a single field called ID if you don't put it in there. So now if I go to properties and I go to fields, I thought it would do that. Maybe I was wrong. But anyway, so now that I meant to add that to my map, my input points. Okay. So I added that to the map. Oh, it added it. Sorry. And then in the older ArcMap interface, we need to start editing, and we need to actually make a point somewhere. So I'm just going to make a point here somewhere in Hattiesburg, right there. Oh. I have to have the editing window, the create features editing window. Add that point in right there. It doesn't really matter where your point ends up. Okay, but now I have that point, and I can stop editing and save the edits. So now I have that point right there. Let's test our tool with that point. Here's my find population tool. Oh yeah, I was going to import the schema from that one and then test it. So now when I run that guy, see how now it actually lets me, if I hit here, it lets me draw my own dot. So I can put dots down, put multiple dots down, or a single dot. So it lets me do that interactively. And in fact, if I want to run it from there, I can do that. So I can hit this guy and hit the dot, and then choose a linear value, let's say 1,000 meters. Now I say okay, and it should run oh, but I didn't make that an output parameter, so it didn't actually add it to the map. But it did run. If we wanted to see it really quick, we could modify this. Let's put a default value in here too, 1,000. Say okay. Make this a model parameter. We're going to take that off in a second, but now I've made it a model parameter. Now if I run this guy, I can click on this into the area and hit OK, and it should run, and it created that. That's actually a circle. If I zoom in there, you can see it. See the circle it created? I could run this guy again, choose something right next door, make it a little bit bigger, 5,000. Run that. See how it got bigger? Moved over. So that's that's a few concepts that we went over there that were perhaps new. Is we used the feature set. Feature set does allow you to choose. So if I run it from here again, feature set does allow you to choose it does allow you to choose the input points themselves. So now if I run it, it's going to should have chosen this one. Let's just choose the one on disk. There we go. Say, let's make this 10,000 so we can see it. Yeah, so it buffered 10,000 meters from that point that I chose in Hattiesburg. All right. So that's working. What we want to do is not make this a model parameter because it's actually not the output. We need to buffer, then we need to intersect, then we need to we actually need to do a dissolve so that we just get the output with the total number of people in the output polygon. All right, so overlay is going to be intersect. So we've got our intersect there. We're going to intersect two things, right? The output, is this called output feature class? Output feature. I'm looking at this output feature. It's called not output feature class. I'm going to rename this so that I know what it's called. I'm going to call it buffer output. Now in here, I'll see buffer output. And the other thing I'm going to buffer is the Mississippi track. I mean, the intersect is the Mississippi tracks. Now, I'm not going to make this a model output, a model parameter. And what that will do is it will hard code that in. And ArcGIS is smart enough to copy this data up onto the server. So I don't have to make this a model parameter because I don't want the user to provide their own tracks. Maybe I do in a different scenario, but this tool is going to be a tool for finding out how many people live within a certain distance of a point click for the Mississippi census data. So they don't have to provide their own data. So that's why this is not a model parameter. And then this will be the buffered values intersected with the census data. And then finally, we need to calculate a field, which I believe is under data management fields. Calculate field. Yep. All right, so drag that guy on there. So what we're going to do here is in this value, we're going to use the buffer intersect result, and we're going to calculate into that final value there, which we called buffer pop. We're going to calculate an expression. I'm going to choose Python because I like Python better than VB. So the expression that we're going to make is the, well, just hit the expression tool. It's the shape area I believe it's this one. I don't know why. The shape area divided by the total area times whatever field you want to use. We're going to use the total population, which I believe is just P0010001. I'm going to put a parenthesis around these guys. I'm going to make sure that that's the right field. I'm going to run this. Oh, I'm going to get empty output generated. So I'm going to add this to, I'm going to make this a model parameter. Hit yes, hit save, and I'm going to try to run this whole thing. So I need to choose a point. And then make that 10,000. And then run it. Okay, cool, it ran. Let's see if the data looks right. Oops. So I have the buffer pop right there is 3886. Actually, in order to see if this works, let's choose one that is on the edge. So this one's on the edge right here. So that's that one right there. So the buffer pop is 4293. Let's see what the overall population was. $5395. So it looks like it's working. It should never be above the value. So this was the census tract, and this, after buffering it, that was the census tract. So now we have the value that we want within that field, because this is the ratio of the total area to the shape area. So it looks like we have about 5/7. I'm just rounding off here. About 5/7 of the total area. So the population is about 5/7. Well, not quite. It's almost 5.5/7 of the population. Okay. So that works great. So now, let's zoom to this one. If I want to report the total population within that circle, then I need to do one more thing, because right now, what's the total population? This represents the population of every census tract in that circle. So how do I get the total population of that circle? Like, maybe just mathematically. If I told you this column represents the population of each census tract in the circle, how do I get the total population? Add them up, right? That's how I do it mathematically. I could write Python code that went in there and read each row individually. Okay? Or what might be easier is to use a GIS tool that's already designed to do that. There's a GIS tool designed to do that called Dissolve. Dissolve will allow me to remove all the boundaries, and come up with one feature, and I can summarize based on whichever field I want. So here I'm going to edit this field. Edit. And I'm going to add dissolve, which I used to never remember where any of the tools were. Okay, dissolve. I always searched for them for a long time. I'm still not that good at it. But, okay, so dissolve. I'm going to rename this guy. Buffer intersect. Output maybe. Or actually, maybe that's what this one's already called. Okay. So now I'm going to connect this guy in here. I know we're due for a break soon. So. Okay, and we're just going to dissolve. We're going to decide what are we going to dissolve on. Well, we're actually not going to dissolve on anything because we've intersected. So we want everything there. If you check on any of these fields, they have to have identical values in order for them to be dissolved. If you don't check on any field, it will dissolve all of the features in that field. All right, so what we want to do, though, is under statistics field, we want to say this new population field, which is buffer pop, and we want to supply the sum of that field. So now the output will be the total population within that field, within that area. I'm going to format this a little bit. There we go. So now it's all formatted. And the last thing to do here really is to set this as a model parameter. Now the user will be able to receive that value. If we didn't make that a model parameter, it wouldn't be an output. So we've got this entire workflow, which is really a fairly simple workflow. There's 4 tools, and it runs. So now, what's the next step if we want to publish this as a geoprocessing service? What do we need to do? I'm going to trash this because we don't even need it anymore. Clear the features. So, what do we need to do to make this a geoprocessing service? Remember from the steps that I said before. First, we build the geoprocessing tool. We get it running the way we want it to run. And we actually haven't tested it yet. But it's okay because what do we need to do to actually run it? To actually publish it? We need to run it. That's the next step. Is we need to run it from the Arc Toolbox window. So we're going to run it, and if it works, we can go ahead and publish it. Because we're ready at that point. So I right-click on Find Population. Not right-click. I just go ahead and open it. It doesn't matter where you're storing the output right now. That doesn't matter. Okay? Because in the end, the output's just going to be online. So here, we need to run it. We need to click somewhere. Let's click up in Jackson this time. And then we need to specify a linear unit. I'm going to do, like I said, you should, I'll do 1,000 because you should choose a small one for your example. We can go 10,000 when we actually try to run it on a server. But you want it to be able to run, more quickly as an example for your users. All right, so I'm going to say OK and see if this works. So it's running. So overall, it took about 4 seconds. So we need to think, we probably could make this a synchronous tool. It's probably OK. It's under 10 seconds. The problem is if somebody accidentally makes this puts in like 1,000,000 for the buffer distance, and then it might take a lot longer to run. It's not going to hurt much except for user experience if they did that, but we could experiment it for a second and see what happens if somebody puts in, let's see if somebody puts in 40,000 and clicks somewhere on the map. Let's see if this takes any longer. I'm just curious to see if it'll take longer. It didn't take any longer. So at least for our data set with that area. Oh, and by the way, let's see if this works. So that's the buffered populations right there. Some buffer pop 474969. That's our estimate of how many people live in that circle. All right. So now we can publish this. And I don't have any problem publishing this fairly large circle because it ran the same amount of time. So what we need to do is look under the results. And then we have our tool running a bunch of times. You need to make sure that you choose the right one. If I went down here and published one of these ones that was previous, it wouldn't work as well. Well, it would publish the previous version of the tool. Not that it wouldn't work as well, it just wouldn't work right at all. So we need to choose this one. And we right-click on Find Population. Share that as a geoprocessing service. Publish it as a service, that's fine. I'm going to cancel out of this real quick. So notice that it uses the default as the name. So I'm going to update it. I might have to rerun it. Let's see what happens. I'm pretty sure I'll have to rerun it. Nope. Okay. So it kind of figured out the name. It was okay with that. Okay. Then I'll hit next. And I'm going to choose to put it in Raber. And I'm going to analyze it real quick and see. Oh, of course, it's going to tell me a few things. First, the find population buffer intersect parameter is missing. Syntax dialog, explanation, blah blah blah. That we got before. We know how to fix that. We need to put in values for these three. Data source used by model find parameter is not registered with the server. What it's doing is telling us that it's going to copy up that data. We know, I told you it was going to do that, and that's fine. There is a way to around that. As I mentioned before, you can put your data in a specific place and say, this is where all my data is. And in those cases, I wouldn't have to copy it. That's just better if you want to manage your own data. So we just need to put in some data here. This is the input points for the location to buffer. Here, you can actually change some of these things. User-defined value is going to be what you choose most often, especially with a feature class. You're not going to want to make it a choice or a constant value unless you have the data on the server to back that up. So in other words, basically you could choose this point or this point or this point. What we really want to be is any point. You specify the point. Constant value in this case would be kind of silly because it would always be returning the same value if we chose that. Distance, that's fine as a user-defined value. This is going to be the distance to buffer the input point. And then finally, this is the result feature with population estimate. And then once we do that, we should be able to publish this just fine. We'll still publish this right now as synchronous, but either this week or next week, I'll show you how to do asynchronous. It's not much different. Publish this. It does call it something else by the URL. This is probably only going to take like 3 minutes to publish, but I still think it's a good time to take a break. So it's probably going to publish like that. Oh. It's taking a few minutes. So I'm going to go ahead and start.